We're going to be looking today at integration by substitution. Okay? What's that? What? You good? Okay. We're doing integration by substitution. I think it's relatively straightforward. As a thing, it's just another thing for you to learn and remember and use. Okay? Just got no rules about it. So, the first question that we're going to look at says, let u equal 2x plus 1. And they do tend to give you the substitution. You don't need to normally work out what substitution to use. So they say, let u equal 2x plus 1, integrate 4x times root 2x plus 1. Yeah. Okay. Yeah. So, does anyone have an idea of how we can do this?
Did you substitute 2x plus 1 with u?
Sorry?
Substitute 2x plus 1 with u.
We are going to replace 2x plus 1 with u. There is something else we're going to do.
Inverse chain rule?
Inverse chain rule. Okay? It is going to be the inverse chain rule, I believe. Let me just double check that. U minus 1 root. No, we're not going to do that.
What's the inverse chain rule? Unless you put it in there. What's the inverse chain rule?
I don't know why they've done du dx for that. Oh, dx. Oh, okay. Alright, alright, yeah, sorry. I was just giving myself a little recap. There we go. Right. So, there's how many different parts are there to that integration?
2.
No.
1.
3 parts. There's 3 parts to this integration. Okay? There's your 4x, okay, which we can all agree is a part. There's a root 2x plus 1, which we can all agree is a part. What's the third part? Dx. Okay? Because we're going to be doing a replacement of x with u, when we integrate it, we need to integrate it with respect to u. Okay, not with respect to x. So that respect to x also needs to be got rid of somehow. Okay? So we know u is equal to 2x plus 1, so we need to think of how we can rewrite this in a form which would allow us to get rid of dx. So what could we do to the u? To get a dx? Not integrate? Differentiate. So if we differentiate u, if u equals 2x plus 1, that means du dx would equal just 2. Okay? And we can rearrange this to find out what dx is. We can bring up the dx and bring down the 2, get du over 2 is equal to dx. So that's going to be one of our replacements. We're going to replace dx with du over 2. Okay? And du over 2 will act like any other term, where you can just multiply 3, you can bring that divide by 2 over if there's a times. Consider this as 3 things terms together, I believe. I'll need to just quickly double check that. Yes, yeah, that's correct. Okay. So, the other thing, obviously you've got 2x plus 1 underneath the root, so we can just replace that with u. We've got 4x, so what else do we need to do? What else do we need to do?
Rearrange
Get it in terms of
x.
Yeah, get this equation here in terms of x, so we can say our other thing is equal to u minus 1 over 2 is equal to x. Okay, so we just rearrange it to find out what x is. So now we can replace the x here with this. We can replace 2x plus 1 with that, and we can replace dx with this. Okay, cool. So it's all about rearranging to get rid of x terms and dx terms. Okay, so when we integrate this, we can say we're going to integrate this as 4 times u minus 1 over 2 times root u, which we can express as u to the power half. I just want me to write root u first for anyone taking notes. I'll write root u first, right? Root u, okay? And then dx, which is now du over 2, okay? Times, okay? So, what does this become? Well, this becomes 2u minus 1, in brackets, times u to the power half, all over 2, with respect to u, okay? Because we can bring the divide by 2 along, which becomes just u minus 1 times u to the power half, because the 2's cancel out with each other, with respect to u, which also becomes integral of u to the power 3 over 2 minus u to the power half. Okay, now we can integrate it. Why is what?
Why is it all over 2?
Because of the du over 2.
Oh, okay.
So I cancel
okay.
that out with that to get just the 2, but there's still a divide by 2 here, which I've just brought along the side. Because times we can move it away, we can separate it out. Okay, so at that point, easy integration. Okay, we should be able to integrate this. Add 1 to the power, divide by the power. So this becomes u to the power 5 over 2. Divide by 5 over 2, which it becomes times by 2 over 5. Okay, minus, boys, u to the power 3 over 2. Divide by that becomes 2/3 plus c. Okay, plus c. Okay, what do we have to do you reckon at the end? Yeah, you've changed x out. We wanted what the integral with respect to x was, so we need to then replace our u terms. Move to x plus 1, so 2/5, 2x plus 1 to the power 5 over 2, minus 2/3, 2x plus 1, 3 over 2, plus c. Okay. Okay, and that's it. Okay. That's the whole process basically, and every time, I'm pretty sure every time we give it you, they will tell you the substitution to use, and it's all just about that rearrangement. Okay. For instance, the next one, which do we want to go through the next one? The next one looks hard. I don't want to do the next one. No, the one after that's probably harder. That's how textbooks don't work. That's what I was discussing with someone yesterday. Oh, it was you. Yeah. Okay. Alright. Okay. Where's my bar rubber? Okay. Everyone okay with me removing that?
No.
I'm going to remove the first half. Okay. So I can start.
Oh, yeah.
What do you mean by expanding space? Yeah, if they give you an x value and a y value, you can use it to find c. Yeah, that can happen. But that's just standard solving for c. Okay. No, you can just type into your calculator. Yeah, if they give you x and y, you can just type all of that into your calculator, take it away from the y value and give you the c value. Okay, alright, so, next one. Let's see how well I do with this. This could go badly. So, x equals 2 tan u. 2 tan u. Okay, that's going to be our substitution. We're replacing x now with 2 tan u. That's why they give you this, because the substitutions can sometimes be horrendous. I do not consider that a lovely substitution. And the equation we're integrating is 8 over x squared plus 4. Thank you. X squared plus 4. So, first thing you always want, or dx, sorry. Thank you. The dx actually becomes real important with these. Often we forget to write the dx down because we're kind of lazy, but the dx becomes super important with this because we need to really consider that the dx exists. Okay? So that the first thing you know that you need to do is change dx over du to sec squared u. Am I right there? Should be right. Hopefully I'm not wrong.
Yeah.
2 sec squared u.
Yeah.
Okay? So that means that dx is equal to 2 sec squared u. Oh no, du over dx, sorry. I've got that wrong way around. Yeah. No.
No, it is.
Yeah,
Yes,
no,
it is.
right. Yeah. Oh, that's even more confusing.
that's harmless.
Yeah, no, that's even more confusing. Alright, so, another point to pay attention to. Obviously, in our previous one we had it u is equal to a term function of x. This time we've got x as a function of u. So when you differentiate it, you do get dx over du, which means that you can just times up by du. So this becomes dx equals 2 sec squared u du. Okay? Previously, it was the other way around and you had a division. Okay? So don't make my mistake. I didn't actually make a mistake, I just thought I made a mistake, and then I realised I didn't make a mistake. It's great. Don't make that mistake. Okay, interesting. Okay, we don't have anything else in terms of an x that we really need to replace. The only thing is x squared, but x squared is just going to be this squared. Okay, so in my replacement, that means I'm going to be integrating a over 4 tan squared u plus 4, because you know you've got to square the 2 as well when you square the tan squared, times 2 sec squared u
This is like trig identity.
du. It's almost like trig identities. It's almost like make you do trig identities with integration after a while, because who doesn't want all that fun in their life? Okay? And I know it sounds like I'm being sarcastic, but I'm also kind of being genuine. I do love a bit of trig. Right, so yeah. Okay. When we combine it as one single fraction, we get 16 sec squared u over 4 tan squared u plus 4. Obviously, there's you can divide 3 by 4 here. Okay, to make it just 4 sec squared u over 4 tan squared u plus 1. Okay, but what else can I now start thinking about?
Tan squared plus 1 equals x squared. Right?
Tan squared plus
Yes.
1 equals x squared. Yeah, yeah, oh yeah, that's even nicer.
Yeah.
I was going to do this slightly differently. I was thinking about yesterday, you know how we did the derivative, if it's the derivative of a function? Well, that wouldn't be the derivative of that, though, would it? No, because that would have to be tan for that to be the derivative. So that wouldn't have worked. Yeah, good identity, Kabir. So, because tan squared plus 1 equals sec squared, yeah, we can say that actually we're integrating 16 sec squared u over 4 lots of sec squared, because we can take out the 4 from here. Yeah? Any questions? Have I done it wrong? No? Is that right? Okay. What? What?
They didn't take out the 4.
I did take out the 4.
Oh, they. Oh.
Yeah, I did a factorization, sorry. Tan squared plus 1.
Oh, yeah.
Yeah, I just skipped it, sorry. Any questions? Everyone okay so far? Okay. What does that become?
I don't know. What do you mean? You just.
No, it just becomes 4.
Yeah.
No, just 4. 4 du. Okay, because sec squared divided by sec squared is 1. And 16 divided by 4 is just 4. So, does anyone know how to integrate 4? 4u, there we go. 4u. Plus c. Someone's dropping backs at the back. 4u plus c. Okay? And what's u? Okay, yeah. Now, this is where we now need to consider the rearrangement of this for finding out what u is. Okay? So it felt very easy to this point, obviously. That's all easy. But we need to rearrange this. X over 2 is tan u. So that must mean the inverse tan of x over 2 is equal to u. So when I replace it over here, 4 lots of inverse tan x over 2 plus c. Fun times. Okay, so what were the key points? So the key points, obviously, replace the terms that are x with the identity they've given you, or a rearrangement if necessary. Okay. differentiate it so that you can get a dx, what dx is equal to, but be careful, it can either be du over dx or it could be dx over du. Just be careful with the manipulation there. Identifying trig identities, kind of key. Okay, potentially. And quite often trig identities do come out to be something nice, like just a sign or a cos or just a number. Okay, so that when you integrate it, it's quite friendly. Okay. Any final questions? Okay. Obviously, this is hard, but it's easy. That's hard.
That's easy.
That's easy.